The next question is, which of the following in reactions are allowed by the conservation laws? The first reaction they are given, pi plus particle interacting with the neutron give lambda 0 plus k plus k on. The next reaction is they are given as pi minus plus p gives lambda 0 and plus k0 particle. So for checking the allowed reaction, we got to check. There are three. So the one is we got to check the charge conservation, whether it is a equation satisfy the charge conservation. So the next check is baryon number consideration for the strong interaction. Baryon number considerations. The next consideration we got to check is strangeness. So there are three consideration we got to check. Then the reaction we can guess whether it is allowed or not. So strangeness consideration. The first reaction we can take. The first reaction pi plus n gives lambda 0 particle and k plus. So first check is charge conservation. This is plus charge plus 1 plus neutron is 0 chargeless particle. Lambda 0 particle is also chargeless particle. K plus is plus 1. So the net charge is conserved. So the Q is conserved charge. Because left hand side is plus 1, right hand side also plus 1. So plus 1 plus 1. It is conserved reactions. Now baryon number consideration. If you see the baryon, the pion is a meson. So there is no baryon number. Here only one baryon is there. Neutron is a baryon category. Lambda 0 particle also baryon category. K plus is boson category. So this is also conserved. Baryon number is conserved. So 1 equal to 1, this is considered. Now strangeness. If you see the pi plus, the strangeness in this particle is 0. In the same in neutron baryon numbers are also 0 because neutron is made up of up, down and down quark. So this strangeness also 0. But lambda 0 particle is made up of UDS. So strangeness is minus 1. The K plus particle is made up of uh, I think one strangeness. So plus 1. So change strangeness also left hand side is 0, right hand side also 0. This is a plus 1 because the kaons is made up of, there are bosons are always made up of two quark. One is conjugate quark, another one is non-conjugate quark. So it is made up of strangeness, conjugate strangeness. So that charge is plus 1. So you can now you can strangeness also considered. You can guess. Now the second reactions. You can check the second reactions. The second reaction. So this reaction is allowed. Now if you are checking the second reactions, pi minus plus p, lambda 0 and then k 0. So the next check is we have to check this equation for the three above three. So you can check the conservation of charges. This is minus 1, proton is plus 1, lambda 0 is 0 charge, k0 also 0 charge. So the total charge is conserved because left and right hand side is 0, left hand side also 0 charge, so q is conserved. Next check is the baryon number consideration. Pi minus particle is bosons, so this is not baryons. P is baryons. Lambda 0 particle also baryon. K0 also is boson. So baryon number is considered. Left hand side one baryon, right hand side is one baryon. So B is considered. So the next check is strangeness considerations. If you see the proton is made up of up and down quark. So strangeness is 0. Lambda 0 particle is strangeness is -1 because it's made up of UDS. So already we know. Now next check is we got to check the pi minus particle. What is the baryon number? So you can the pi minus particle there is no baryon, so that is also 0. Then you can check another one quantity, the k 0. Already we know the k plus baryon number is s minus. So k0 is the opposite particle. K0 also s minus. So the baryon number is conserved. So baryon number is conserved. Strangeness also conserved. The left hand side is 0, right hand side is 0. So strangeness is conserved. So the given two equations, the first one, second one, the both are allowed. The reaction is allowed. So reaction for option is 1.